All right, so we're looking at the language of hypothesis testing, 10.1. So hypothesis is a statement regarding a characteristic of one or more populations. And hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations. All right. Of course, if I scroll up, you still copying, let me know. All right, steps in hypothesis testing. So this is basically saying if you had to start from scratch, how you go about doing so. You'll make a statement regarding the nature of the population. You'll collect evidence, sample data, because basically, we're getting a hypothesis or conclusion of a population based on sample data. So you collect evidence to test the statement. And then you analyze the data to assess the plausibility of the statement. All right, anybody still copying?
No, I'm okay.
Okay, all right. All right, so here we have our null hypothesis. There are two types of hypotheses or hypotheses. So anyway, there are two. We have our null hypothesis. It's denoted by HO, which is H naught. You would say H naught. It's the statement to be tested. It's a statement of no change. I forgot my E right here. Of no change, no effect, or no difference, and is assumed true until evidence indicates otherwise. That probably should be a D right there. Assume true. Yeah. Whatever. Find a book. I don't remember a D being there. All right. Now your alternative hypothesis is H1, and is the statement that we are trying to find evidence to support.
Okay.
All right. All right. Anybody else? Everybody good?
I mean, I'm good. I can't speak for everybody else, but I'm good.
Okay. Yeah, I just want, because then when I move too fast, then I mess people up. So I try to give people a chance to write the stuff down.
I know, and they're like, oh, no, and it's like, oh, okay.
All right. So we have 3 tests. We have our two-tailed, and let me erase some of this stuff. So we'll Go here. Our two-tailed test. It's two-tailed because you see we have two tails here, right and left. And as we go and progress throughout the course, throughout the testing process, you'll see why it's two-tailed. But just know it will be two-tailed. Also, notice the difference between two-tailed, left-tailed, right-tailed is just the symbol right here. And you'll see in a second that there will be keywords that will dictate what symbol we use. But if you notice that everything else is the same when it comes to either one of your tests. So when it comes to H naught, your null hypothesis, you will always have the equal sign there, no matter what test you're using. Left tail, less than, you use the less than symbol. Right tail will be greater than, use the greater than symbol. So let me erase this stuff so y'all can copy it though, no problems. So you'll have a parameter, that's going to be the same. You have a value, that's going to be the same. And then, like I said, you have that word symbol right here that will change according to what you're dealing with or what your key phrase is. Also, left-tailed and right-tailed tests are considered one-tailed tests.
I'm okay.
All right. And the next one's where we got some words to copy. Yep. Oh, I could have left that. Let me see it. No, I'm not even gonna mess with that. I've already hit something. All right. So here, determine the null and alternative hypothesis. State whether the test is two-tailed, left-tailed, or right-tailed. And so for the first one, we have the Medco pharmaceutical company has just developed a new antibiotic for children. 2% of children taking competing antibiotics experience headaches as a side effect. A researcher for the Food and Drug Administration wishes to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. So, like I said, I'll give you a chance to write that, and then we'll go ahead and establish what our null and alternative hypotheses are. All right, so this is how we'll set this up. So we will use P as our parameter because of the percent. All right. And this 2% as a decimal is 0.02, and that's what we're using here. Once again, your null hypothesis is always going to be equal. And the researcher wants to know if the side effect is more than 0.02 or more than 2%, and that more than is this greater than symbol. All right. So more than 2% is this statement right here. And that's how you would set it up. And of course, it's right-tailed because it's more than. All right. Any problems with that one before we go to the next one?
So far, so good.
Mhm. Good. All right, next one. The Blue Book price of a used 3-year-old Chevy Corvette is $86,012. Grant wonders if the mean price of a used 3-year-old Chevy Corvette in Miami is different from 86,012. All right. So this one is going to be two-tailed for us. Keyword here is different. So we're not talking about more than or less than. It could be either or. We just want to know, is it different? So that's why we would use not equal. So not equal is different. And then we use the mean symbol right here because that's what we're talking about, the mean. That's why we have our mean symbol. And of course, the 8612 is the number that we're comparing. We want to know, is it different from 8612? So whenever that's the case, that's going to be two-tailed for us. All right, problems with that? All right, last one like this. We have a standard deviation of the contents in a 64-ounce bottle of detergent using an old filling machine is 0.23 ounces. The manufacturer wants to know if a new filling machine has less variability. All right, so we have a standard deviation here, so we use our standard deviation symbol. As always, that's equal. 0.23 is what we're using here as our comparison, and we want to know if it's less than, or has less variability. And so that means to be left-tailed. So greater than will be right-tailed, less than is left-tailed, and then not equal to is two-tailed. Any questions? Any questions? good. All right. So now there are four possible outcomes. First, possible to reject the null hypothesis when the alternative hypothesis is true. So that's fine. We should be doing that. Next, do not reject the null hypothesis when the null hypothesis is true. That's fine to do that. Now the next two are errors. It's possible to reject the null hypothesis when the null hypothesis is actually true. And it's possible to not reject the null hypothesis when the alternative hypothesis is true. So number 3 is a type 1 error, and number 4 is a type 2 error. All right. Problems with that? Let's scroll up. All right. Level of significance is denoted by alpha, Greek letter alpha, and that's the probability of making a type 1 error. So that one's going to be chosen for us in this book. Or when I say in this book, when we go about doing our exercises. Talk about that more in a second. All right, so let's go to my other sheet. I made those notes and left off something that I wanted to make sure we were good on. So starting here, alpha I just mentioned was the probability of making a type 1 error, but there's also beta. It's Greek letter B, or Greek letter beta. It looks like a B, but it has a little extended stem coming out of it at the bottom. So Greek letter beta is the probability of making a type 2 error. So the probability of making a type 1 error is chosen by the researcher before the sample data are collected. So like I said, this will give you, the exercises you guys get will give you alpha first, but if you were doing this from scratch, you would choose your alpha, just level of significance, and you'll see why in a second and what would dictate your choice. The choice of the level of significance alpha depends on the consequences of making a type 1 error. All right, so if the consequences are severe, alpha should be small. Example of that is alpha equal to 0.01. If the consequences are not severe, alpha can be higher, 0.05 or 0.10. All right, so the level of significance is not always set at 0.0, the smallest, 0.01, because reducing alpha increases the probability of beta. So just got to count the costs, which one matters the most to you, whether it's the probability of having a type 1 error or the probability of having a type 2 error. And that's because they have an inverse relationship. As one goes up, the other one goes down. All right, questions on that? All right, so that is it for 10.1. I believe, yep, that's it for 10.1. So next class we'll be doing 10.2, looking at actually implementing hypothesis testing, and then that'll be it. That'll be it for as far as new material is concerned. We'll be looking to close out the semester. So we have a final exam. All of your other tests are posted. So now we have a final exam. Remember, the final exam will be proctored. I'm going to send out directions. Probably send it to you either today or tomorrow on, the date, time, and all the good stuff like that. So I'll give you 2 hours to take it and everything like that. And it'll be in that first week of May. That's our final exam week. What else? Have to see exactly what, because I've already given you guys chapter 7, 8 tests. So I have to hash out because I have to do you guys final exam different than I did last semester. So like I said, you guys made it to chapter 10. You and my other class. Last semester we didn't get there. I think it was just a lot of stuff going on trying to get adjusted to the new norm, so it was kind of hard to just knock the stuff out. But yeah, so we'll talk about what the final exam is going to be on and dates and all the good stuff like that, dates and times and all that, and directions. Make sure we understand that you log on to Zoom, you stay on Zoom during the test. You just go to another window, all that stuff, and make sure everybody's clear. And I will provide a makeup opportunity. It's just that you do have to take the initial final first, because I have to encourage you guys to come in and actually take the test, because there's supposed to be at some point a moment where I actually see you guys doing something. You know what I mean? Other than that, you could have had anybody just doing your work for you. So so to the best of what we have as far as technology is concerned, we're going to have a proctor test, so that final exam proctor. So outside of that, that's all I have for today. Any other questions, concerns, or comments before we close? Everybody good? Everybody?
No, that's it.
All right, sounds good. Sounds good. All right, well, you guys have a good one. Be safe. Have a great weekend, and I'll see you on Tuesday.
All right, bye. Thank you.
Take it
Yeah,
easy,
take
sir.
care. You do the same.